Welcome back to Further Maths in an Empty Classroom with me, Mr. Southern. This is the fourth video on vector geometry, and in this video I'm just going to be doing a slightly more gangster question that's got a perpendicular line going into it. So here we go then. With respect to a fixed origin O, the line L1 has equation r equals 2i plus j minus 3k plus lambda I minus 3j plus 10k. We're given that the point C has position vector 3i minus 2j minus k, and that the point P lies on L1 such that CP is perpendicular to L1. Right, I'm just going to draw this scenario here. I've got a line here, which is L1. I've got a point P that lies on L1, so let's label that there and call that the point P. And then I've got this point C over here, which is 3 minus 2 minus 1. And I'm given that C to P is perpendicular to L1. Now this point P that I'm trying to find, as in the previous example, I could define that using the vector equation that I've been given. So I can write 2 plus lambda, 1 minus 3 lambda, and negative 3 plus 10 lambda as a vector, position vector for the point P. Now, I'm told that CP is perpendicular to L1, so that means that C to P, when I dot that with L1, is going to equal 0. Now, the previous one, the vector we were trying to find was relative to the origin O, so we could just use the position vector. Now we actually need a vector C to P, so I'm just going to deal with this here. To get the vector C to P, we're going to need to do P minus C, so 2 plus lambda, 1 minus 3 lambda, and negative 3 plus 10 lambda. And we're going to need to subtract from that the vector C, which is 3, negative 2, negative 1. Now just be careful with signs here. That's going to give us lambda minus 1. It's going to give us 3 minus 3 lambda. And then for the last one, it's going to give us negative 2 plus 10 lambda. So just check that. Subtract 3, I get negative 1. Add 2, I get positive 3. And add 1, I get negative 2. Yeah, happy with that. So that's C to P. Now, when I dot that with L1, I've got to use the direction vector of L1 here. So what that means is that lambda minus 1, 3 minus 3 lambda, minus 2 plus 10 lambda, which is my vector C to P. When I dot that with 1 minus 3, 10, I need to get the answer 0. So let's just set that up to find lambda then. So I've got one lot of lambda minus 1, minus 3 lots of 3 minus 3 lambda, plus 10 lots of negative 2 plus 10 lambda equaling 0. So lambda minus 1 minus 9 plus 9 lambda minus 20 plus 100 lambda equals 0. So let's just tidy that up here. I've got 110 lambda equaling 30, which means that lambda is the rather beautiful 3 over 11. And what I now need to do is I found lambda, so I need to substitute that into P to find my position vector of P. So I'm just going to do that over here in a slightly different color. So I've got 2 plus 3 over 11. I've then got 1 minus 3 lots of 3 over 11. And then for my K, I've got 1 plus 10 lots of 3 over 11. Right, 2 plus 3 over 11, that comes out as 25 over 11. Then I've got 1 take away 3 lots of 3 over 11, so that's 2 over 11. And then I've got negative 3 plus 10 lots, so hang on, that's going to be 30 over 11 take away, so that's going to be negative 3 over 11. Absolutely beautiful there. We're asked for exact coordinates, which means that my point P is going to be 25 over 11, 2 over 11, negative 3 over 11. Now, this is the kind of question that students mess up the whole time because rather than working out that vector C to P, they just use the position vector of P. We could do that in the previous one because it was relative to O. As soon as it's relative to a different vector, we've got to find that direction vector that takes us from C to P and dot that with the direction vector of L1. And then we come out with that rather beautiful solution. Thank you very much for listening, if indeed you still are.